So I want to sketch the following regions R, then express this double integral over the region of f of r theta dA as an iterated integral over R. And I want the region inside the lemmicon R equals 1 plus 1/2 cosine theta. Now, we can start doing this point by point, which you've done back in Calc 2. Hopefully you remember what it looks like. Actually, it would be a good exercise for you to pull out a couple points and see just what happens. But let's jump to Mathematica and take a look at it. Here's your lemmicon. Kind of comes in a little bit and then goes back out. So really what I'm looking for are my bounds so I can integrate that function f of r theta in polar coordinates. Well, the radius r is going to go from 0 to this function, and this function is 1 plus cosine theta over 2. And then theta, obviously this goes all the way around, is going to go from 0 to 2 pi. So I can make this double integral. And the function is going to be some function that's still undefined, but r of f of r theta, r dr d theta. And r is going to go from 0 to 1 plus cosine theta over 2, which is just that thing right there. And then theta, in this case, will in fact go from 0 to 2 pi. So that is an iterated integral. I just don't actually have the actual function that I'm integrating. So let's take a look at the next one, because the next one I think is very similar to this. I've got the region outside this circle, r equals 1/2, and inside the cardioid, r equals 1 plus cosine theta. Okay, I should probably take a look and see what this thing looks like. Here is a 1 plus cosine theta. It's the cardioid. If you look at it, from this angle, it looks like a heart on its side. So what I want to do is I also want to plot that circle r equals, I forgot what it was, 1/2. R equals 1/2. So let's go ahead and give it a circle r equals 1/2. So I'm just going to modify this code just a tad. Here we go. So what is it that I'm actually looking for? I want the region outside the circle and inside the cardioid. So what I need is actually outside the circle, inside the cardioid. So this is, I need all of this. That means what I need to find is the intersection point here and the intersection point here. Because I need to come around like this. I don't want to go out beyond this point because I'm going to have the wrong portion. And so I need to start here probably. So I need to find those two coordinates. And the way I'm going to find them is really pretty straightforward. All I'm going to do is take 1 plus cosine of theta and set that equal to 1/2. I just need to solve it for when those guys are equal. So that means that, or that implies that cosine of theta will equal a negative 1/2. That means that theta equals negative 2 pi over 3, and theta equals positive 2 pi over 3. See, negative 2 pi over 3 is over here, right? Because think of this as being 0, so coming negative 2/3 of a pi. And the positive 2/3 of pi is going to be up over here, like that. So I need to actually integrate from, theta has to go from negative 2 pi over 3 all the way to 2 pi over 3. So back to my iterated integral. I now know my bounds. I have some function f of r theta, and it's going to be r dr d theta. And the radius will go from this circle 1/2 to here, so it's going to be 1/2 to 1 plus cosine of theta. And theta, we just said, is equal to, or goes from negative 2 pi over 3 to a positive 2 pi over 3. So there's my integrated or iterated integral.